All right, the final thing that we are going to talk about in this lecture for Numpy is analyzing data in Numpy arrays. So how do you actually analyze that data? And we're going to distinguish two different approaches that you can use. So one is element by element manipulations. So if you want to modify each element of the data in some sort of way. And then the other will be summary functions. And so this involves grouping some of this data together. So we'll see examples of both of these. So we have our array data. And Numpy is kind of designed to make element manipulations very easy. So we haven't covered looping yet, and typically you don't ever need to loop through an array in order to analyze it. So like if we wanted to do something like add 2 to every single element, you might think we do something like this, and then data. Modify the element, in some way. So element plus 2, something like that. So we can definitely loop through every single element and then add 2 to it, and then we could potentially modify the original array that way. But kind of the way it's designed is that they've modified these operators, for example, the plus operator, to do that automatically. So what does the Numpy operator do when you give it an integer? How does it add a Numpy array object to an integer? Well, to know the details of that, you need to know the details of the add magic method of that class. And so the way it's been implemented is that it simply just adds 2 to every single element. So it adds 2 to -100, so we get -98. It adds 2 to 3, so we get 5, and so on and so forth. And this is pretty much how all of the different operators work. So if we use the minus operator, if we use the multiply operator, if we use the division operator, if we use the power operator, it does this to every single element of the array. And so you'll notice that what is returned is an array of the exact same size. So in each case, an array of identical shape is returned, and each element has been modified. Numpy also has a large number of built-in functions. So these functions also act. So when I talk about built-in, so these are attached to the Numpy module. But then there's a bunch of methods or a bunch of functions that if you give it a Numpy array, kind of the way it operates is that it does this on every single element. So if you take the sine of 10,000, you get this number right here. The sine of 9 is equal to this. So we have a way to do element by element functions so that each element has the function applied to it. And there's actually a huge list of these. So if you go to that link within the lecture notes, you can see there's all sorts of trigonometric functions that are available: sine, cosine, tan, arcsine, etc. So hopefully you remember some of these from your days of doing trigonometry in high school. Hyperbolic functions, so these are also trigonometric functions: hyperbolic sine, hyperbolic cosine, etc. And then rounding, and so on and so forth. Logarithms, exponentials. Some of these are a little bit kind of more complicated, but you can see that there's really a large number. Some of them are specialized for complex numbers. So if you're ever looking to do something, most likely this has already been implemented in Numpy, and you simply just need to find the right function in order to do that. So what happens when you try to add 2? So we've seen what happens when you add an integer to a Numpy array. What happens when you add 2 Numpy arrays together? So let's make a second Numpy array. So we'll just multiply the first array times 2. So you can see we have the second array, which is double the first array. So for example, we can add those together. And so what you can see is it does element by element addition. So what do we mean by that? So let me get this next to each other. All right, so if we try to add this to this, we see that we get an array with the same shape, and this element is equal to the first element of data plus the first element of data m. Same with this one, so 3 plus 6 is 9, again, and so forth. And so this kind of shows you Numpy's desire to allow element by element manipulations that also extends to doing operators of two arrays. And again, you can do this with subtraction, you can do this with multiplication, and you can do this with division, and you can even do it with power if you want. So unfortunately, you cannot take integers to a negative power, but if we gave it the appropriate data, then it would work. So these are examples of how you can do mathematics on each individual element. But sometimes you might want to also do summary functions. And so Numpy also has a large number of functions that allow you to perform some sort of statistical analysis of your data. So what it does is it groups the data together and calculates some sort of summary function. So an example of that is the mean. So if you wanted the mean of the data, so these are attached as methods. So we're no longer using functions that are attached to Numpy. So one of the things to note is that we are now moving to a method of the Numpy array called mean. And so if we do that, it just simply does the mean of these 5 values. So the mean is taken by adding these 5 values together and then dividing by the shape, by the length of it. There's also, for example, sum, so we could calculate it by doing something like this, and then that gets the same number. So we could calculate mean by summing up all of them together and then dividing by the shape. So again, there's a large number of these types of functions that are available, and these can be found, a number of these can be found at this website right here. So we have used mean, and you can see both the mean, and then you can also see kind of like what are some of your available options that you can use for that. Standard deviation, the variance, the weighted average. So if you want to calculate a weighted average, median, there's really all sorts of different summary functions that are useful. Histogram is something that can be very useful function to use, or useful method to use. Quantiles, etc., etc. So you want to use these methods for sure because these are optimized to be very efficient and will do it much faster. So if you want to calculate this, it'll be much faster than anything that you kind of implement yourself. Another note is, when you have two-dimensional data, you also have a lot more options when you do summary functions. And this is a little bit tricky when you first start to use them, but eventually it starts to become very, obvious, and also it becomes very useful. You'll be surprised by how useful it might be. So if we take the mean of a two-dimensional array, it adds all 6 of these numbers together and then divides by 6. So it just does it for the entire array. And the same thing is true if we do it, standard deviation. But we might not always want to do it like this. Sometimes we might want to take the mean of just part of it. So, if we wanted to calculate the mean of the rows, so if we wanted to know what is the mean of this first row and the mean of the second row, or maybe we wanted to take the mean of the columns. This is also something that's very easy and possible in Numpy. And so how do you do this? So you rely on this this argument called axis. So mean, standard deviation, all of these summary functions take in this optional argument called axis. And so this specifies if we don't want to calculate the mean of the entire array, we can calculate it in certain directions, in certain dimensions. So, we'll see this example for 2. So we provide an axis of equal to 0 and then an axis of equal to 1. So in the first case, what is returned is a array of shape 3. And so what has happened is it's taken the mean by grouping the columns together. So the average of 2 and 1 is 1.5, the average of 3 and 5 is 4, and then the average of 4 and 6 is 5. If we change the dimension to 1, so if we change the axis keyword to 1, now it's going to average over the rows. So 2 plus 3 plus 4, so that is equal to 9. So 9, and 9 divided by 3 is 3. So the mean of this row is 3, and then the mean of this row right here is 4. So we also have a lot of control if we don't want to condense the entire array down to a single number, but if we only want to condense down to like a certain number of dimensions. And you can also do this with 3D arrays. So if we just do data 3 and we do the mean, so if we don't provide it with the axis keyword, then we take the mean of the entire thing. But we can also specify individual axes that we want to do the mean over. And we can actually even specify 2 axes. So this is almost taking like the mean of a plane of the data. So why might you want to do this? So you might want to do this if you're, for example, if you have a movie. So if you have a movie of RGB values where you have frames, you have 2-dimensional pictures of RGB values, and then going through time. So maybe you want the average, for each point in time. You can think about that for the depth data that I showed you in the research example, where you have the depth, and you might want to average at each time frame how large is the bower, and so you can use your axis, and instead of supplying it with an integer, you supply it with a tuple that gives you both of the dimensions that you want to kind of collapse down on. And so you can do any combination that you want, and you can kind of collapse in any sort of direction. All right, so this is just supposed to give you a kind of a flavor. So there's this Numpy is such a huge and awesome resource that I can't really cover the majority of the things that it's able to do. My goal is just to get you to the point where it's easier for you to figure this out on your own. So at some point, you might have some sort of script that you need to make, you have some sort of research that you need to do, and so hopefully this prepares you better in order to use Numpy in order to do that.